तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः।
Last time we met, you had witnessed a demo on traffic light controller, which was left flowing traffic, and we did not see the user constraint file for the same. So what is shown here is precisely the same, and you need to put that in a separate file. Let us say traffic underscore controller.ucf in order to do this, and locate it in the same folder where traffic controller.edf is located. This EDF file you have generated by using the simplify synthesis tool, and there is no compulsion for you to locate it in the same folder, although it is preferable just for the sake of locating it readily and nothing else. And these are all the pins you will have to list. For example, you will have to declare it as net, and you can use any of the standard editor, say WordPad or Notepad or whatever. And this is the pin that you have to mention. It is to signal to the tool that you want to locate, use this clock signal as pin 89, because we are now concerned with the hardware connection on the FPGA. And this user constraint file abbreviated as .ucf is precisely to tell the tool that such and such pin is to be taken as a particular signal. For example, 3 input signals are clock, blink and reset underscore n, which we have already seen quite a number of times, and we had 16 lamps, say LEDs, and these are all the nomenclature we adopted for main. M stands for the main and S for side, and we had its 4 road junction meeting point, and R stands for the red, and there are 2 roads in the main. M stands for the main. So main red 1, similarly main road 2 indicate the very same main road, and you have also yellow light for the same, and you just keep track of number of outputs that you are going to see. And on the right is listed the actual pins, and we have MY1 and main yellow 1 and 2, and followed by green and right, each of which is for 1 and 2. And you also have a side road, and precisely the same definitions follow suit for this side road as well. See, side road red 1 and 2, and then yellow and green, and so also for the right. And I think this completes the 16 outputs for the traffic light controller. And so what we have seen so far is the left hand side traffic, and that is in the Asian countries, and in European and US you have right flowing traffic. And so what is depicted is a right flowing traffic right here. It's a 2-lane traffic here, although generally in expressways etc. you have 3 ways, and in freeways in US you have 6 ways for each of the 2 directions. So, and there will be a median there, and where there is no real concrete structure on the median, you will have a double yellow line there, and each of the lanes will be separated by a white line. And notice that one more white part is there. This is normally for parking. So there will be another white line for closely here, and that will be the cycle lane. And normally when you pull onto the sides, you will have to see that it is after the cycle lane and right on the curb. So the right side of your wheel will have to be within this 18 inch from the curb. And here I have assumed a free right turn, and therefore on all directions you can see a free right turn here. And what is depicted here is the left flowing traffic, left turn, and naturally this is the right flowing traffic. And let us say we have earlier to this it was a straight going traffic. If you want to go straight, you should not use this lane, because this is generally meant for the left flowing traffic. Of course, in Indian roads you do not really comply with all these rules and regulations, but in US and other things they strictly adhere to this. And so this unwritten law that they should take to this leftmost lane, otherwise you will have problem. If you get here you may get stranded. And this track or the lane is for free right as well as for the straight flow traffic. So when straight traffic resumes, it will go straight here. And we have seen earlier left flowing traffic. What is shown here is the right flowing traffic precisely for the same sequence. And one such sequence was S2 earlier for left flowing traffic, and the very same sequence is maintained here for the right flowing traffic. Now of late you would have noticed on the roads there are timers displayed on the with a big display. Each of the display is actually comprised of some 15 LEDs or so for each of the segments. For example, this you are already used to. There is a 7-segment display A through F and G, and with a right decimal point, and same thing I have put over here with so that we can form a bigger display. And each of the segments will have some 15 LEDs or so in this placement shown here, and there is also a decimal point here. And the flexibility that you have is you can put it any other size you want. You can, what all you have to do is add more number of LEDs, and the interface circuit that you need will be as shown here. So for example, you have what is called a ULN 2003. This is a device available. It's actually a Darlington pair, and input is coming from the FPGA output. Say one of the lights that you have already seen, main, red, etc. They are all single bit outputs. They are all connected here, and this is just a typical representative circuit for one of the traffic lights. And each of this one, and if you go for the higher display, what we have seen, higher size display, you need typical for one segment this group of LEDs, and they are all cascaded and shown here as a series connection. And note that when an LED conducts it, so it will take up approximately 1.5 volts. If you put 15 of them, naturally it calls for, I think it's 22.5 volts. So if you have a supply voltage of 25 volts, so the difference around 2 volts would be dropped across this resistor, and this resistor would turn out to be around 200 ohms. Individual segment has been shown here, and so this is the actually exploded display that you may like to configure, and individual segment of which we have already seen here. And circuitry is quite simple. This 2003 can go right up to 50 volts. That's why you can connect a 50 volts here, and if you wish you can have some more LEDs here, and you have to select the resistance in such a fashion. Some around 10 milliamps which is safe current rating for the LED passes through this. And suppose instead of LED you want to drive a solenoid or relay, say solenoid, you can go right up to 500 milliamps. So you can use this same thing circuit for some other purpose. So to drive a solid state relay, you require a different setup as such, which we may see in future. And so this is the assignment we are actually seeing for you in order to include 2-digit display for the display of timer. And I will read out the assignment first, then explain the same. For each of the 4 directions, we have a 4 road meeting point, junction point, and that is what we mean by 4 here. What we had said, main road 1, 2 and side road 1 and 2. So all this together would form 4 directions, and from each of the direction you will be as a road user you will be facing the traffic lights, and alongside that you have 2-digit display, and that display must be quite big enough so as to so that it is visible from a long distance. And so you have to provide a 2-digit display to indicate how much time is left or for the respective traffic flow to start or stop as the case may be. So this I will explain once again after showing that traffic light we have seen before. And as the case may be for that part of the road, the displays count down and have range from 99 to 0 seconds. Formulate an optimum scheme and incorporate it in the traffic controller we have designed before. And let us have a look at the signal we have already seen. And in this case, what holds good for this equally holds good for the left flowing traffic. And for earlier we have given this as an assignment to you, if you would remember, and asking you to recode what we had done earlier for the left flowing traffic, and I hope you have not done that, because there is no need for you. So the reason is, this is nothing but a mirror reflection of left flowing traffic. So you don't really have to do any coding at all. Absolutely no recoding is necessary, not even a single character need to be changed. Precisely the very same code will work on this, and for a simple reason that this is nothing other than a mirror reflection. In fact, if you can go on to the other side of this 2D, what you see here, what you will actually see is only left flowing traffic. So what all it amounts to is, instead of putting this outputs here, it was right here. So that is precisely what you will see if you go at the other side of this figure, and that happens to be just a mirror reflection, and therefore you don't need to have any recoding. And this particular sequence is actually shown here on this board. You can just have a look at this, and this will be clear from this, and precisely the same left flowing traffic that you have here is what is shown there. Now coming back to the next assignment what we have been discussing earlier, and that is to provide 2-digit display for the timing, and you will be for each of this set here you will be putting 2-digit display and facing this traffic. If it is left flowing traffic, this group will come over there, otherwise there is no difference. Now let us see what the implications are. For example, let us say earlier there was a straight flowing traffic here, it was going this way, and we have said that straight flowing traffic is timed for 45 seconds and another 5 seconds for the yellow transition. So that would take you 50 seconds, and for left flowing traffic, even from main road to side road, we have given timing of 20 seconds plus 5 seconds for the yellow. So in total you have 50 plus 25, 75 seconds, and you will have to wait if you are on the side road. You can't avail the thing, because first what is allowed is straight flow traffic followed by the left flow traffic for the main road, and the all other things will follow suit, except for side road. This will be main flow will be 25 seconds and turn also will be 25 seconds. So you have to take into consideration all this, and then accordingly design the timer and see and enable them when to start, when to stop. So for instance, let us say the main flow traffic has just commenced. So if you look here, the 2-digit will be initially set to 50 seconds because you have 45 seconds plus 5 seconds transition which will go straight here. After this the same counter will be reset to 25 and allow this traffic flow, and this is inclusive of 5 seconds once again for yellow light, and having done that one the total is 75 seconds. All along there would be another timer running here, and that would be running from 75 to 0. So whereas here it would be first 50 seconds then followed by 25 seconds and then going over to 0, and like this you have to take care for each of the direction. I hope you understand. Is it clear to you, all of you, that this assignment? So this completes the one of the applications, say traffic light controller. We will be going for the next application, and in the meanwhile I have seen that there some change of software as far as the Xilink is concerned. We had earlier used a design manager for place and route as well as for back annotation. So what we are going to now see is the Navigator for used for the same purpose, and once again I have given the command summary here. This is place and route and back annotation using Xilink's project Navigator. This version is 6.1i, and what is loaded on this machine is 6.2i. I do not see any much difference between the two versions, and these are, I hope, are the latest ones. And this is the command summary that we have here. I will read out and then go on to the actual tool, and alternately, and if you have any doubt please stop me at any point of time. And we will have a Navigator here. So for example, so you can see the icon here, and the icon here is here. I hope you are able to see there, and this is project Navigator, and the same icon is shown right here. So what you just click on this one in order to invoke this window to open the Navigator window. Inside the Navigator I will just read partially and then go over to the actual tool. Inside the Navigator click on file and then new project. So any starting you make will have to be as a new project. If it is for a second time you can open the existing file. So here it happens to be a new project, and when we really go into the tool we may not have this invoked, and it may straight away enter into the already created project. And I have verified and I have asked other engineers also to verify, so I do not think any problem will arise even if I bypass some of these steps. And anyway I will read out and explain this. And this opens a new window called by the same name, and whatever is the file name that you have given for the project, and that is for the new project. In that window type the decide project name and select the project location. So where you have located your project, where you want to locate the project will be given over here, and usually this will be a place where you have already put in all your source codes and simplify outputs such as EDF file or user consent file, which we will be requiring for this particular Navigator, and all this you may house in a particular folder, and that is what we mean. And right in that folder you can create a new project going by the same name. For example, if it is a real time clock or a traffic light controller, you name it as such, and select the project location, that is the folder where you want to locate the Xilink's project. And top level module type, there is another subclass in that menu called top level module type, and you have to choose it as edif. It will become clear to you when we look into the actual Navigator window, which I will be opening shortly. And then you follow it as click on next, followed by selecting the decide input design. And the input design, mind you, we are right now doing the place and route. So, and this implies that we have already run the synthesis tool, which is simplified tool that we have already used earlier, and using which we created a .edf file. If it is a traffic underscore controller .v as your design, you will get traffic underscore controller .edf as the simplify output, and that will be the input for this design manager, or right now the latest tool is the Navigator tool, which we are explaining right now. and that will take in .edf file, and you also need a constraints file, and this constraint file we have seen an example for traffic controller constraint file earlier with a dot extension UCF extension file containing the FPGA pin connections, and obviously it contains the pin connections here which are keyed in for the project that you are executing now. Right now you are executing a particular project and for which the UCF file will have to be taken. Then click on next. This opens another window reporting the device selected in simplified tool, and this is what we have selected actually in simplify, and automatically in this tool it will know what device you have mapped using the simplified tool and so on. So that will be automatically taken care which will be apparent when we go further steps, and this opens another window reporting the device selected in simplified tool of course, and edif opted. So you have opted for edif in this place and route tool. Make sure to mention model sim for simulator selection and click on finish in new project information window. The device.edf and .ucf files selected are listed in sources in project window in the main navigator. So when we open the navigator we will see all these windows. So click on the, we will come back to this step once again after we see the window. Click on .edf file. In the window mark process for source, various options for implement back annotation and creation of bitstream, that is .bit files appear. So with this first point we will go on to the actual navigator, and this is the main project navigator which is obtained after clicking on the navigator icon, and I am afraid it will not be readable to you those who see the TV monitor, and I am going to show a exploded view on this, and before that I think you can make out at least some patch of white light here, white here, and one more window here. These are all basically windows, and if I double click somewhere here you will get another window energized, and you see in total 4 types of window. This window is known as sources in project, and it is here where you will get the EDF file and UCF file, and you will have to key in here, and then you can even change these files if you want to go for some other project. And another window is processes for source, and here what is listed is implement design and map, place and route, all this. There are wide varieties of place and route, we will see one after another, and then finally to generate a bit file we need a generate programming file. I will zoomed version I will show you in a minute now, and this is the very, I mean you go from one part of the tool to another, and you also have what is known as a floor design. You can see the actual layout of what you have put into the FPGA, and so first let us, and there is a window here. When you start implementing, what all you have to do is go to a particular thing and double click. For example, if I click on this implement design, say for example if I double click it will run on this, and there is a tick mark here. I wonder whether you can notice the tick mark and on the monitor, and if you do then you will see a question mark here if I rerun the thing. Say for example I can click on the right and you see another small window opening, there is a rerun and rerun all. So if I press rerun, now it will start running. Now you can see a question mark here, and it will keep on running and it will keep reporting on this window. Now let us have the zoomed window of that. So what you see is the zoomed window here. So if, as I mentioned, sources in project window is this. You can see for example this is what we are going to cover as our next design application, for example a real time clock, and abbreviated as RTC, and there are several versions were there, and don't worry about the actual name here. This is the actual EDF file. Unfortunately because it is large we can't see the whole thing here, but know that it is just a .edf extension, and you also need a constraint file which is rtc.ucf here, and this is what is presented in the first sources in project window. And if you go down, you will see the processes for source, and once again very same project name is indicated here, and you can see only partially here. Implement design is what we have already seen there, I have explained to you, and you can see the question, not question marks, the tick marks very clearly here. And you have a translate, and then you can do a translation report. If you want to see the actual layout, FPGA layout, you can invoke, double click on this floor plan design in order to invoke the same. And the device that you have mapped, and what you need is what is called mapping, and you also, after mapping is done, you have a map report as well, and these are all various map reports available. And there are many features here. I can't take it here because it's in it's only copied in the paint, so I have only to show, I can only read out here. When you go to the actual, this is the actual real window of the Navigator, and if I can drag this here, because the earlier thing you have zoomed version you have seen, I can't drag because it is just a snapshot there. If you go here, what you see here is the last one is the generate programming file. This I already explained, and this covers most of, all the points of, point 1 we have already seen here, and so we will go on to the point 2. This is what we have seen, process for source, various options for implement back annotation and creation of bitstream files appear. We have already seen this, and so the second point is we need to start the implementation. So if you want to implement design, so what you do is just double click on the implement design on the processes for source window. This is the second window that we have already seen, zoomed version as well, and to start the implementation of the place and route. After it is completed, that is after tick marks appear, this is what we have seen there, and double click on map report. If you click on the map report to open implementation details on the log files window on the right, it reports the, I will read it fully and then go on to the window to show the same. It reports the gate count, number of slices or LUTs used in the project, etc. For this particular project. Also look into errors and warnings if there are any, and do the needful as you had done while using the Xilink design manager earlier. This you are already used to correcting, and a number of trials you will have to make till you get a really working code on the FPGA. And so you have to double click on text based place and route static timing report for viewing maximum frequency of operation. If you are interested in finding out what is the maximum frequency of operation, that you can work on the real hardware, so you will have to click on to this, double click on text based place and route static timing report. So before we go on to the second one, third one, and this is bit generation, and we will have a look once again here. So this is the zoomed version, and what I said is there is a window here down, and which keeps on reporting when you double click on implementation here, implement design. If you double click on this, it will, that will run. So let us have a look at the actual. Okay, it's asking, sometimes it will ask whether to reload or not, and I just said no for the time being. Let us see what we have here. See, let us this implement design, we have, you remember I had given rerun and it has completed. Earlier when I gave rerun, and there was a question mark implying that it was running. Now having completed, and it would give a tick mark. For example, I want to see the translation report. What you do is just click on the translation report, double click on the translation report. On the right you get the report here, and here it simply says number of errors is 0, number of warnings is 0. This is for the next project that you are going to take up. This is a real time clock. RTC_alarm is the design file, and if you want further details, mapping report, you can just go to map here and then click on map report, double click on that one, and out comes this. Here what you have is we have already read these points, and it reports number of slices, and for example this RTC requires some just 275 slices of flip flops out of 18,000 on the device. The device that we have used earlier was also the same device, say 800, because that happens to be the board that we have, and similarly 4 input LUTs that have been consumed is just 641 out of 18,000 and odd. Let us not go into the details of this, which we are going to cover in the next application when we take it up, and it is sufficient to say that it merely reports number of what is the get count. For example, here it reports get count here, say 7,000 and odd, and JTAG IOBs, and a part of the get count we can take, and all are reported only in this map report here, and there is also a place and route. You have once again a place and route report here, and it gives in more detail, for example which pin was connected to which point, and what IOBs are used, and all pin listing it is giving, and also what clocks are used, and once again number of slices used, and so on. And it also gives the timing summary here. Let us not go into the details right now. When we come to that design, we will see this, and basically the timing details, and finally it says place and route there are no errors, and that is what is here. And next one is, we have seen implementation, then mapping, then place and route, and you also have a pad report separately, and that will list all the IO pins that have been connected here, and that is what you see here on the right. It may be difficult for you to read, and that is why I am explaining that, and when you actually start using the tool, you will understand this clearly. And anyway, the command summary gives the exact directions, so you will have no difficulty on using the tool, and some post place route static timing also available there, and we have and generate programming file here, and if you this is also a question mark. For example, if I want to run this one, what all I have to do is just rerun that and let it run, and when it runs you see that some activity is taking place. So the last window is precisely to report what activity is going on, and right now you can see it is 50% of the job completed as far as generating the bit file is concerned. So what we will do is, we will go on to the zoomed part once again, and to see whether we have left out anything. So this sources in project is the first window which we have seen, which will give you the EDF and UCF file, and this is the implementation file called the sources process for source, and you have implement, mapping, and place and route, and then generate stream, and this is what is the to report the actual activity that is going on, and we can drag this here, and going to this part on the top, you see the report window that you have already seen here. This is the report window. So all the activities will be reported here, and that is the meaning by saying log files here, and we will go back to the command summary once again. So we have completed 2 points. So we will see the third point. In order to create the bitstream file, double click on generate programming file. After it is completed, double click on programming file generation report. This is precisely what we have done to cross check that the design output file .bit extension is created, and that is over earlier. So a tick mark is got, and in this file, if you see towards the end, I will just read out. It may be difficult for you to read yourself. So what all it says is saving bitstream in RTC_alarm.bit. So this implies that bitstream generation is complete. That is what it reports at the towards the end. And coming back to the this command summary, we were here. This is the file downloaded to the FPGA housed on the target circuit board while checking your design on the hardware later on. And if you want security of your design, you have to do the following procedure. And if security of your design is required, right click on generate programming file properties, which opens the window named process properties. Click on read back options. In the drop down menu of security value, select disable read back and reconfiguration. that is in the project navigator. So, you have it here. So, if you right click, you have properties here. The machine is rather slow, I think you will have to put up with that. So, what you have here is property name value, this is the window that opened, and you see here enable readback like this. If I click on this arrow, you have disabled readback, disable readback and reconfiguration, right. This is the option that I have mentioned in the text right now, and if you click on this and then say OK, that is what is meant there, and again there is a question mark because you have changed the same. And coming back to this command summary once again, and that is what we have seen here. And if once you did this one, and the bit files cannot be read by any other people. So, this will prevent piracy or stealing of your designs if you happen to be an IPIC or developer, and this is a very vital thing for most of the companies. And we have some notes here, 2 notes here. If you change any of the constraints or the floor plan, you will have to run the place and route, back annotation and bitstream generation again. Whenever you change the design file or the constraint file, run the simplify and then the navigator tools again. In order to run implement design etc., right click on the same and click rerun or rerun all. This is what we have already done. And double click on floor plan design. In implement design, translate to relocate pins, components etc. if you wish to improve the timing. So, this will have a glance at this as well. So, for example, right here at the implementation here, and you see a floor plan design here. If I double click this, a floor plan will be opened here. So, what you see here is the actual your FPGA, you have say for example, this is for the real time clock which I mentioned. Suppose there are some displays on that, what you have already seen in the IO card that we have used earlier, and which is right there here, and suppose this is display 1. Suppose you want to get this here, what you can do is just hold that, click on the mouse and then hold it without releasing it and get it into this area. Suppose you put it here, and you have got this part of the what you have written as a display code, and that part of the module is portrayed here, and this is the actual periphery depicts the actual pins. You can zoom on this. I will show this. For example, I want to zoom here. What I do is just click on the right. So, you see a zoom to box. I will just read out for you, and I can just mark the window here and it will zoom there. So, and you have a plus minus, you can use this zoom as well, and you just see that zooming happens now. You can see some faint character also appearing there, and they are all I am not sure whether this is slice what they care, I mean have mentioned, and it is nothing but a collection of some mugs etc. When I zoom, it will be clear to you. So, this is the highest zoom that you have, and unfortunately you can't see much here. So, what you do is there is one more symbol here shown as a gate. So, if you click on this, let us see whether you get that. So, you see faint marks here. I am not sure whether you can see on the TV monitor there, and you have 4 input mugs here, like that 4 of them are there here, and it's 2 are already here, and 4 flip flops are there. It may be Q bar may be there, then preset etc. clock input all are available, and in addition to that 4 2 input mugs are also there. So, you can call this as one block of logic block, or I do not know really what that terminology is, Xilink terminology is, and suppose you want to relocate this one from here to somewhere else, let us say here, you are free to do so. So, you have the flexibility of changing, that is vetoing the Xilink's place and route, what it has already done. You can overrule that one and place it elsewhere, and similarly you can go on to a particular pin, and you see what here the lines are precisely going to the pins. For example, one of the pins may be somewhere here. Let us see, there is a pin here, but unfortunately it is not connected to that, I think there. I hope will be in a position to see one of the pins. You can see here. Suppose I want to relocate these pins, I am not happy with the timing that I have got, I want to improve on the timing. So, what you do is you can just take this one, pick it up, then locate somewhere here. So, you can go to a pin where you want to locate. For example, I want to put it here. So, I just release that. So, if I am not happy, I can change my mind a number of times, relocate anywhere, and then what you do is you have to there is one under file you have one what is called save I am sorry write constraints file. If you click on this constraints file, so you can save the very constraint file, you can these are all relocated pins, and once again you have to run the implement. After that the new changes that you have made either in the form of relocating the components and or the pin will be shown here, and this is what is floor plan. This will be done only at the fag end of your project. And coming back to the command summary here, so we have already seen how to back annotate using the Xilink's design manager earlier. Now we are going to see in the navigator that we are looking into this back annotation. So, right click on post place and route simulation model followed by properties, which opens a window called process properties, which we have already seen. Under general simulation model properties, select model sim verilog. In that one menu part of the menu will be this model sim selection, and you will have to select this particular thing. In value field opposite simulation model target, and click OK, and double click on post place and route simulation model to generate this. Suppose you have an RTC as your design, I have just mentioned your design, you put your rail design here, and you are now what we are talking about is to back annotate. Back annotation is the process by which gate delays are reflected. Only that is the true reflection of your final FPGA hardware that is going to be, and do not be misled by the simulation running at gigahertz, right, and in future we will have a look at that as well. And this, after you do this one, it creates the back annotated file, Xilink's place and route navigator tool that you are seeing now is what is going to generate this one after you run this. Just now we have got this, and it creates two files. One is the times underscore time sim. If your design is RTC, you put RTC underscore time sim dot v and RTC underscore time sim dot SDF. This is the one which contains delay information. So, standard delay format is the expansion of this, and dot v is the back annotated file. If you open this file, and you will see that all primitives are used. Primitives in sense what has been put in the FPGA, such as a mux and so on, flip flops and so on. These are back annotated files which you need to simulate again in order to check whether your design is working at the maximum frequency reported in serial number 2 or not. So, we have already got that maximum frequency reported in one of the files, serial number 2, that we have already seen. And what you do is, although this is not necessary to copy it in a different folder, it is a good practice to do so, because you will not confuse with your design file, and test bench especially you need to modify, because now it has to reflect the back annotated file instead of your actual design. For example, if it is RTC, this is what this Xilink's tool has created, and it is better, it is good practice to have it in a different folder. So, you put this one, these two back annotated files that you have just now seen earlier, as well as library file is also to be put. This is available in this path, C, Xilink's, Verilog, source, then global. There are global variables. This is mandatory, because this contains the information of all the primitives such as mux, etc., that is being used in the actual device, FPGA device. And you also need your design underscore test. This is the test bench we have already seen. Into a new folder, back annotate. So, just give some appropriate name as I have done here. In the test bench, you have to do some following changes. Change include, this is statement that you include for including your design. Your design, say for example RTC.v is actually design here, and this was the original file in your test bench. Now you had to change this as your design underscore time sim.v. You are replacing this file by this backconnected file, and you have also a clock there, and it was defined as clock period by 2, which is as the name implies, it is this 10 nanosecond implies it is 20 nanosecond frequency. So as a ready reckoner I have given a formula here. 500 divided by clock period by 2 will give you straight away in megahertz. For example, if you want if for 10 you get a 50 megahertz here, equal to or less than the maximum frequency reported in serial number 2, which we have already seen. So see that the frequency that you select, that is this value you select is such that the operation frequency is less than what is reported as the maximum frequency. Then as we have seen earlier while using the design manager, and now we are seeing using the very same thing we are doing using the navigator, and then you need to invoke the model sim in order to load your backconnected file, which will actually reflect the gate delays, and without this your project I once again maintain that it is not complete unless you go through the entire exercise of backconnection. And open model sim, file, new project, enter the project name and location of project backconnected, and click on design, compile. This we have already seen a number of times earlier. Select the files your design underscore test.v, then global.v. I am not going to show the model sim again, I am just going to read out before winding up this, and click on default options, and in the compile HDL source files everything is given verbatim. You will have no difficulty in following this same sequence when you handle the tool. Compile HDL source files dialog box followed by Verilog tab. So when you do this, also click on the button library search and specify the library directory as C Xilinx Verilog source simprims. In fact, earlier in the design manager, earlier comment summary, whatever you have used for backconnection will also work as it is. This is only an alternative I am giving here. If you want, these are all more like menu driven, so you have only to click the mouse, keep on clicking, whereas earlier you used to key the actual comments. So this is an alternative approach. If you don't want to use this technique, you can use the previous ones, and directory as this Xilinx Verilog source simprims, and then click on the button extension and select .v, say OK, and then compile, click on done. So this compilation is over, taking into consideration the backconnected file. So next step is automatically to load your design, which is done by click on design, load design, click on global, and here follow it very carefully. If you violate this sequence, it will report error. So click on global, it will always list in the same folder, and then click on add. So after this, don't press the load immediately, right? Be patient and do this second thing also. Do the same for your design underscore test. This is the test bench, right? First is that global, and followed by then say add, and then your design. So in the executing window at the bottom, you will have both the files located in the same opened window. So only then click on load, right? If you just click after this, promptly you will get an error. So take care here, and there is no other difficulty other than this here, and if you follow this sequence, there will be no difficulty. Then open the waveform and run simulation as you have done before to ensure your design is working perfectly, right? And we have seen the command summary for this navigator, which is actually design manager's replacement. I think in the new latest softwares, this is what you have to handle. So if you happen to go for procuring the new things, software, you have to adopt this technique. So it's worth it, and it won't take much time, maybe 1 hour time you can very easily learn. And so this is the projected view which we have already seen. If you have any specific question on what we have covered, you are free to ask. You have any questions? I think we have seen all the report files listed here, and generate file also we have seen, although the question mark is put here, and a dot bit file we have created, which we have opened the report file and then see that seen this. So, if you want you can rerun for we have another minute or so. So, you can just watch what is happening at this window. So, I will just say it is already stopped. So, I think we will have to rerun some of this.
No,
You have a question, please.
No, the question is this: as a designer, when should I move on the components or move on the muxes? Okay, or should I, after every design, should I check it out? Check out whether I should do some manually.
Yes. Okay. See, if you recollect what I have spoken several lectures before, while explaining the entire design flow, the design is, any design is an iterative process. So, you have to do run through all the tools, start coding, run through all the tools and repeat this n number of times till you are totally satisfied, both at the simulation point as well as the synthesis as well as the place and route. So, in spite of running all through, it may not, the place and route tool will not put it very efficiently. After all, no tool can equal human intelligence. So, it is the human which can make the right judgment. So, the human is vitally interested in a particular project solely from performance point of view, how efficiently a design is working, how fast the design is working. So, if you are interested in making a design which will work the optimum speed, that is the highest possible speed, naturally it calls intervention from the human. So, the designer will have to interact and interactively relocate, so that the end goal of jacking up the speed of the system is actually done, right. And from this point of view, we are trying to relocate, not just to play around with the tool. So, it is not out of play, but out of the dire necessity that we want to enhance the speed of operation. For example, you can see different modules are distributed over here. It's the pins are connected over a long distance here, and this would naturally impediment will be an impediment for the high speed of operation. So, you have to relocate these pins as close as possible, so that you may enhance the speed. And this is the reason why we want to relocate both the modules as well as pins. Thank you.